so for this recording and class, we're just trying to understand the y equals mx plus b formula. That is a formula for a line. And we're going to use the Henry example. So we're looking at this formula here. And in your book on page 32, it talks about those letters. So just again, this little letter M is rate of change, B's y-intercept. So Henry's graph over to the left has this equation here. You guys see that? Right? He starts at 45 meters because he gets a head start. And then he goes up 10 meters for every 10 seconds. And so his rate of change is 10 meters for 10 seconds. And so that ends up being just 1 meter per second. That's his rate of change. So thumbs up, thumbs down on that. Okay. So in algebra, instead of calling that a rate of change, sometimes they just assign that the letter M. They call it M. And so if you look at Henry's equation right here, where we had D equals T plus 45, or maybe you had D equals 45 plus T. You might have even had a 1T. From now on, you're going to see it written with the y-intercept second. It's just what is standard. Even though, like in the word problem about Henry, it sort of made sense to put it first because that's where he started. So, like sometimes what I do is I still think of it as first, so I'll say D equals Henry started at 45 meters since it was positive, and then I just sort of work right to left. But I know he went 1 meter per second. That was his rate of change. So I still kind of think that way. So when you look at the y equals mx plus b stuff in the book, and we're going to practice this, so it's not going to make total sense instantly. But I'm just going to show you what this is b. B is where it crosses the x-axis. B is 45. And then m, right here, that's m. M is the coefficient, or the number that goes in front of the variable, or the rate of change. And then, so it seems like just to make it more confusing, traditional books, they tend to always like to use y equals y's and x's, because on our graphs, like your graph for Henry was distance and time. So we did distance was equal to time plus 45. But basically, you just want to get used to seeing that this is also just the x-axis. So, in other words, you could think of this as the x-axis, and this as the y-axis. And so now they will say y equals x plus 45. So the whole point of the book reading is just to show you that when you have a word problem, we really like to use logical variables like d for distance and t for time. But today you're also going to have problems that aren't word problems. And so you're going to have variables x and y. So for example, down in these pictures here, you see no word problem, and so that's why you use x and y. So I'm going to make a sample for you with a real graph. So let me just pause this. So now you have to take the learning from the actual problems and try to make an equation when there's not really a word problem, but just an algebra problem like this picture. So let me shrink it up a little bit. So the goal is we want to know how to write the line equation using y equals mx plus d. And remember, b is where it hits the y-axis. So where does b hit the y-axis? 4. At 0, 4. at this coordinate. So we just say b equals 4. And then to find the rate of change, we find 2 exact points and look at the triangle. We went up 2 over 4. Okay? So for the rate of change, we look at the change in y. Do you know that when you put a little triangle, that means the change in y? They do that in high school, over the change in x. It's like shorthand for writing a whole phrase. The change in y is 2, and the change in x is 4. So that reduces by 2. So that's 1/2. And so we say the rate of change is just 1/2, or from now on in an algebra class, just like m is 1/2. Okay? And then you just write your equation. You have to keep an x and a y in the problem. So the equation is going to be y equals what? Anybody know, Caroline? It is confusing at first. So y equals, find your m, your rate of change. So like over here, so my m is the 2 divided by 4, which is 1/2. So we would write 1/2 x plus the rate of, that's the rate of change plus where does it start on the axes?
Why does it have to x?
Good question. This stays permanent and this stays permanent, just like distance and time. And the other things you have to put the actual numbers in. Because we'll talk more about this, but y and x can change. Like for example, when x is 0, y is 4. And when x is 4, y is 6. So they change all the time. But they always change at the same rate, up 2 over 4. So the rate never changes, so we put a number in the place of it. And the graph is always going to start at 4, so we put a 4 here. So that's like your final answer. So we have to practice. Should we try one? Okay. So I just bring another graph in, okay? And then I'll make pictures of these and snip them to notes. So I'm just going to put a graph in. I can even put in the graph with negatives and positives and it still works. So like I just have to pick some points. So like I could put a point here and I could put a point, I don't want to make it like here. And then I could draw the line. And I'll make those points in color so you can see them better. Which means I have to find my pen again. Okay, here it is. So watch. Here's a point, and here's a point. And I want to write an equation, and it's always going to be in this form. So I think Matthew kind of has it. Can you tell me where the graph hits the y-axis?
At 0, 3.
At 0, 3. So we say b equals 3, because that's where it hits the y-axis. Okay, Emily, can you figure out, like, what would be my first step to find the rate of change? What do I always draw? Make a triangle. So to find the rate of change, you make a triangle. And it goes up 1, 2, 3, 4, 5, and 2. You see that? So my change, my triangle, remember how we were doing those little ratio tables, like comparing the y to the x and dividing them? So I go up 5 for every 2. Whoops. So I'm going to divide by 2, and I get 2.5. Do you see that? Does that make sense? So my rate of change is 2.5. Yeah, but do you see that? Can you give me a thumbs up if you do? Oh, okay, so we're getting there, not everybody. So you can also write it like this, 5 halves. They mean the same thing. So, yeah, exactly. So the equation is just y equals 2.5x plus 3. That's all you do. So I'm going to pause for a minute. So we're going to go to your packet so you can fill some of this in, but let's look at some of what we started with. Like up here, it's a little hard to see this. This was 1t. So the rate of change is just 1. Remember, m just means rate of change. And if they asked you what b was, there is no b, so you say 0, which means it started at 0. That's from your old packet. So for Gilberto, his rate of change is 2. Remember, he got like $2 per kilometer or something. Okay, and Leanne's rate of change was 2.5. So it's just the coefficient. Okay, but when we look at Henry, which we did just a few minutes ago, Henry's rate of change was that one right here. But his starting, like, remember he got a head start, so his y-axis starting value is 45. That's a 4. You get that? So this was Henry. Remember he started 45 meters ahead?
How do you know which one's always?
It's always the coefficient. It's always before the variable. And like Emil, so his m value is his rate of change. He went 2.5 meters per second. But where did he start? He started at the starting line, right? That's why his b value is 0. Okay? And we can look at these guys later. They're just other examples. But let's do one of these because I sense that you need to do another one of these. So on your packet, it's a little easier to see. This is a 3. And these are counting by ones, right? So I'm going to zoom in. I can. A little more. So if I want to write an equation, I need to find the rate of change. So I just find any 2 triangles. Is any triangle through 2 exact points. So this one goes up 2 over 1. But like somebody else might have done a different triangle and gone up 4 over 2. You see that? It doesn't really matter as long as you reduce. So my x value compared to my y value, and that little triangle means changing y and changing x. I went up 4 for every 2 that I went over. And if I reduce that, I get my rate of change is just 2. That's my m value, or my rate of change. Where does the graph hit the y-axis? Yeah, Tyler.
0.
At 0, 3. So this is my b value. So that's also called the y-intercept.
So are you always trying to get x to 2? Or I mean to 1?
Yeah, you're always trying to get x to 1, exactly. Or you could leave it as a fraction. But right now we're just working on it as the fraction was 2 over 1, so we just write it as 2. So my equation is just going to be y equals, so what do I have, Derek? 2x plus 3. And is it linear? Is it a line?
Yep.
Is it decreasing? No. Is it proportional?
No.
Because it doesn't hit the y-axis. Okay? So let's hold on to solution for a minute. We're going to skip that for a minute. We're going to practice one more graph. So I'm going to pause, and you guys are going to try the next graph. Okay? So I'm seeing a couple of things, right? Like I'm seeing triangles. Like if I made my triangle here, I go up 2, right 1. So my rate of change is just 2 over 1, which is 2. Thumbs up or thumbs down? Okay. It turns out the y-intercept is also 2, right? It's just a coincidence that because that's the y-intercept. So, sorry, that should be a 2. And what did you get for your equation?
I got y equals 2x plus 2.
Y equals 2x plus 2. Right. So walking around the room, these are the questions I saw were common. It's not always easy for people to tell increasing and decreasing at first because you need you need a little more examples. So like if I look at let me bring this up. The next page and compare them. See if it's going left to right downhill. Over here, this is decreasing. You guys see that? So this would be a decreasing. And this would be what? Decreasing. And this one? Increasing. Increasing, right? Okay. So, hold on. So the question about solutions, I want to do one more graph, and then we'll talk about solutions, and that's all we're going to do today. We aren't going to finish everything. So I'm going to blow up the right-hand side of the page, not literally. Okay. So when your graph is decreasing, your rate of change is no longer positive. You know, because it's going down. So if you look at this page a little closer, like I'm going from here down and to the right. So my rate of change here, yeah, it's like down 1 over 1. So we'd say it's a -1 rate of change. Do you get that? And so m is just equal to -1. And where does it start on the graph? 10. I should say, where does it cross the y-axis? It crosses at 10. So my equation, I'm going to try it. Let's start. Elliot. It is not proportional because it doesn't start at 0, but it is linear. Do you remember that? Yeah. It has to go through 0, 0. Okay, Jacob, what's the equation?
Y equals -1 x plus 10.
Perfect. Okay. So, this is how you tell if something's a solution. When you look at the question, is this a solution? Going back on the first page I had up, and I had that big green point. If it is a solution, that just means the point is on the line. So is the point 3,9 on the line? Go to this picture over here and go over 3 and then project up. What is 3,9? So you're going to go over to 3 and look up. Is that the point 3,9? Yes. So it is a solution. Now go to the problem below. Is the point 3,3 on this line? No, right? Like 3,3 is right. 1, 2, 3 right here. I'll zoom in because it's a little small. So do you see I go over 3, up 3, that's 3, 3, right? Because I'm asking, is 3, 3 a solution? I made them up for you, so you can write them in, yeah.
But if you didn't make up the numbers,
You have to have a question. I put that in. I made it up. You would have to be asked that. No, I made them up for you. They just weren't typed in. So I can't say is blank a solution. I would have to ask you. So I'm asking you, is 3, 3 a solution? And you're going to say no.
I get what you're saying.
It's not on the line, right? Derek, does that help? There's other things we're going to talk about solutions, but not today. Okay? We're just going to say, is it on the line or is it not on the line? All right? So, yeah, let's take a minute for questions. So, number 3, well, before we do number 3, do you want to tell us what you got for number 2 here?
Yeah, so the rate of change is -2.
Okay, so I'm going to check, and he says -2, so I see going down 4 and right 2. I use that because my screen's kind of not blown up. It was also down 2 over 1, right?
Yeah.
So either way, so the y over the x, the change in y over the change in x is down 4 over 2 or down 2 over 1, so it's 2, negative.
Yeah.
It's decreasing, and somebody asked about proportionality. Is it or not?
No.
No, because it doesn't start at 0, 0, but it is linear. Okay, what's the y-intercept? Keep going.
It is 4.
Right?
Why is it not proportional?
Because I was not paying attention to my pencil. Thank you. It is not proportional, it is linear. Thank you, Emily.
And then the equation is y equals -2x plus 4.
Yes. Is 3, -2 a solution? You have to see if it's on the graph. So go to 3,
Oh, yeah.
right here, right?
Yes. Wait.
It's on the line. It lands on the line, right?
Yeah.
So we say yes. So this one's increasing. Is it proportional? This one right here?
No.
No. Is it linear?
Are you going to show us today?
Pardon me?
Are you going to show us?
Yes, I'll hand it to you. Okay, what's the rate of change here? Up how many?
2.
Over how many?
2.
Okay. So the change in y over the change in x is up 2 over 2, which is just 1. Where does it start on the y-axis? -2. So -2.
How do you know that? Because there's like a
Because it's below 0. No, it has to cross the y-axis.
Oh, okay. Oh, cross the line.
The y-axis. It has to cross the vertical axis. So the equation would be y equals 1x minus 2 or plus -2. So you can write it like that.
Where did you start to draw your triangle? 1 minus 2.
You need an x. Jesse, you start at any exact point. So if I zoom in, I see these little purple points. I could have just gone up 1 over 1.
Oh, okay.
Okay. Practice the book work tonight.